Okay, it's recording. Um, so welcome to the second part of SwiftUI. Last class we talked about briefly about SwiftUI. We introduced it. So I'm going to quickly do a recap of SwiftUI. If you weren't here on Wednesday, I'll quickly introduce myself. I'm Vin. I was the course instructor last semester. This semester I'm the iOS lead. But yeah. Alright, so to quickly recap, we discussed what SwiftUI is. It's basically a declarative framework, similar to how UIKit is an imperative framework. It was written in 2019 to replace UIKits. It's the future, so if you do develop apps in the future, it's highly recommended that you use SwiftUI over UIKit. So we discussed the difference between declarative versus imperative. So declarative is defining what tasks should be accomplished. So I used this analogy last time where you have me asking Liam to come to Duffield. So that's the what's task. That's the task that I'm asking him to do. Whereas if I were to approach it in an imperative way, I would have to define how I would do things. So I give him a list of step-by-step instructions on how I want him to come to Duff. Now this right here on the right-hand side, that is very annoying. Which is why SwiftUI was created to prevent or to make you not have to deal with all that annoyingness of UI kits. Then we discussed how a SwiftUI, or whenever you create a brand new SwiftUI project, what it looks like. So you have a struct called content view that conforms to a protocol called view. So anything that you draw on the screen must conform to this protocol. There is one required property, which is body. So everything that you want in this view must be inside of this body property. And also last lecture, I talked about how you can create sub-views and then nest it inside of this one body property to make your code a lot more organized. And then inside of here, I create a text. Again, it's a struct, it's a view, and I pass in hello world. We also discussed why SwiftUI uses structs for views. In UIKit, you have classes provided by the UIKit framework. You have a UI label, a UI button. But then SwiftUI, we use structs instead. That's because structs are a lot faster than classes. They live in the stack instead of the heap space. So it's very quick and efficient to delete a struct. It's also a lot more simple. Structs do not support inheritance. And so you want your views to be very dumb and simple. It should not contain any logic at all. All it should do is just take in some data and output it as some view. We also discussed how the order in which you add these modifiers matter. So whenever you're adding a modifier, you're essentially creating a brand new struct. So whenever I add a background before a padding, I don't have that inner padding because a background gets created first and then the padding gets created. Whereas if I were to swap it, I would then get the padding with the background inside of it. We also discussed layouts, which is a way to kind of position your views in the app. We have three main stacks: H stack, V stack, and Z stack. Then we talked about a spacer, which is basically a view that pushes views as far apart as it can. Okay, so that was last lecture. Does anyone have any questions about it? All right, perfect. So this lecture, I'm going to discuss, start off with navigation. So in lecture 3, we talked about how you have a view controller, you have a UI navigation controller, which is essentially just a navigation stack where you push these view controllers on top of, and then you're able to pop them. So SwiftUI, you have something similar. So I have a navigation stack. Again, this is also a struct. It's a view. This is a view that displays a root view and allows you to push other views on top of it. You can also add modifiers to the stack. So for example, if I want a navigation title, I would have to use this .navigation title modifier. Now notice that we put the modifier inside of the view, nested inside of this navigation view. Navigation view and navigation stack, they're basically the same thing. This is just outdated. The newer version for iOS 16 is navigation stack. But yeah, same thing. If you were to add a modifier, that modifier must go inside of the view, inside of the navigation stack. You don't add that to the navigation stack itself. So now, how do we push some view onto this navigation stack? So we create a new view called a navigation link. Now, there are many ways to kind of use this navigation link. This syntax is often preferred. So inside of here, you would present the view that will be presented, or you would put the view that will be pushed. Whereas, or in this label, trailing closure, what you have is a view that is being tapped on. This could be an image, it could be a button, it could be a text. So that is the thing that's being tapped on. This is the thing that is being pushed. Again, these must contain views. So I'm going to quickly demo a how to push some view. So if you clone the repository, the course textbook has, let's see, underneath lecture 10, there's a clone code thing that you can copy. I'll give y'all like 15 seconds to do that. Okay, so if you run the starter code, you should get something like this. Now, my goal is to click on this View Birds button and be able to push this view. So this view was created last class. So my goal is to click on this button and push this other view. So this is my code right here. As you can see, this is from last lecture. I have a birdless view. And at the end of last lecture, I factored this out into a separate view. Normally, you want to create your views and then write them in separate files just to keep your code base a lot more organized. So now content view currently contains this right here. It's a VStack containing a profile view. So this right here is the profile view. And then this is the View Birds button. Now when I tap on this button, you can see that nothing is happening. So my goal is to push this bird list view whenever I click on this button. So first, what you want to do is wrap everything inside of a navigation stack. So to do that, I can create a navigation stack and then pass in every view that I want to be inside of this navigation stack inside of it. So that's the first step. Next, I want to use a navigation link to be able to push this birdless view. So this right here is a button, right, which is some view. So what I'm going to do is wrap this inside of a navigation link. Now the view that gets tapped on goes down here, and the view that gets pushed will go on top of here. So the view that I want to push is this birdless view. So now if I click on this View Birds button, you can see that it pushes this view right here. So you see that it's a lot more simple than UI Kit. I declare what I want. I want a navigation link. I want this to be pushed. I want this to be the label. Now, I want to add some title. Let's call it Birds List, for example. So to do that, I don't want to add that modifier to the navigation stack itself. You must add it to the view that is inside of the stack. So that view would be Bird List view. So I'm going to go inside of this file and just give it a title. Let's say Birds List. So now if I go here, click on View Birds, you can see that it now has a title called Birds List. Okay, are there any questions? Yeah, so if you are behind and didn't get all of that, there's actually a way to, like, I don't know if they mentioned this in the course, but there is a way to, like, switch to a different branch. If you do, like, you can just stash your changes if you do git stash. and then do get switch or get checkout, and then the name of the branch. I don't think it's like one dash layouts or something. If you do this, it will switch it to your branch and have your code updated to where I'm at. Okay, so now that was navigation. Now let's try to make our app a lot more complicated. Let's give it some logic. So now my goal is to add a button called add counts. If I click on this count button, it should increment that value inside of the count text by 1 every time. So let me try to do that. So because this, or let me first create the view itself. I'm gonna copy this button right here. Let's call it add birds button, or add count button. Let's call the text add count, and I believe it was orange, so I'm gonna make it orange. Now I'm gonna add this to this view birds button, so I'll just create an H stack and then add count button. Nice. Okay, so now my goal is to have this count button increments some count by 1 every time. So I'm gonna replace this add count button with an actual button. So I can just say button here. Now what goes inside of here is what you want to do whenever you click on the button. Down here you have a label, which is the view that holds this button. So this is what the button looks like. This is what the button will do. So right now it does nothing. So my goal is to increment some count by 1. Now, how do I make both of these properties share some counts? Well, what I can do is, let's just create an account property in the struct, and let's use it inside of here. So I can use string interpolation to pass in the count there. All right, now let's initialize it to, let's say, 0. So this thing is loading. You can now see that I have this count property that gets initialized to 0, and I add it to this text right here. Now my goal is to put or increment count by 1. So let me try to do that. Right, count plus equals 1. Now you can see that it's giving me an error. Right, it's saying self is not mutable. So why is it saying self is not mutable? Well, remember, structs, or SwiftUI use structs for views, and structs are immutable. Whenever you change a property, that entire struct gets deleted. So, if I were to change this count by 1, add 1 to it, this entire view gets deleted. So, how do we make it so that I can keep, or I can change the value of count without it giving me this error? Now that's where property wrappers come in. So there's a property wrapper called @state. So if I add @state to this property wrapper, it allows this property to be mutable. So what this does is that it looks at this count property. If this value were to change, all views will be updated automatically. So that's kind of like the declarative approach. In UIKit, if you click on a button, you would have to tell it how to update. Whereas in this case, if I update count right here, I don't need to update the view because SwiftUI does that for me. I don't need to change a UI labels text because this text right here contains this count property. Whenever I add this @state property wrapper, it's able to look for changes in this property and be able to update the view automatically. So now my code doesn't yell at me. If I click on this add account, you can see that as soon as I change this property, this text view gets updated instantly. So you can see that it's a lot more neater than UIKit. Okay, so, does anyone have any questions about that? one thing to mention, because so this view owns this property, it also creates it. In that case, you don't want to share it to any other view. So it's often good practice to mark this as private as well. This is also recommended by Apple. Okay. So next up, I am going to introduce these two text fields. So my goal is to add some name to the text field. If I hit add bird, if I go to the bird list, I have this new bird representing a newbie on the iOS team. I'll add them into this list right here. So that's my goal. So let's first create these text fields. So instead of the name right here, I'm going to replace it with a text field. Make this a text field. Now it's missing something. I need to pass it something in. So it takes in some text, right? So let me just create a property. One thing to note is that you don't always need to add @state before every property. This is a common thing that I've seen in a lot of students. Even when I'm interviewing candidates, they sometimes add @state to properties that don't need mutability. You only want to add @state if you know that you want to change it and you want your views to be updated when they change. But in this case, when I change the text field, I want it to change. So I'm going to do @state private var name. Let's give it a string and make it empty. Let's do the same thing for location. Okay, so I create those properties. Now what I'm going to do is pass them into the text field. So name will take in name, location will take in location. Now you can see that Xcode still yells at me. It's not satisfied with this name property. So if I click on this right here, it's telling me to insert a $sign because this text field expects a binding of a string instead of a string. So what's different between this text versus a text field? Well, this text, all it does is that it reads in the value of count. It only reads this property count. The text field not only reads it, it also writes to it. Because it's also writing to this property, you want to add a $sign, which essentially creates a two-way binding. In other words, a read and a write to this property. So by adding a $sign, it's saying that this text field can read the value of name and it can also write to that property. So if I were to write to it, I can assume that this name property right here will have the value of whatever is inside of this text field. So now my goal is to create a brand new bird and append it to some list. So I have a list of birds right here. My goal is to create a new bird object and add it to this list. So what I'm going to do is have a button. So I'm going to create a new button called add bird button. So I'll make it green and add that right here. So add bird button here, and then just simply copy and paste this code over right here. So now my goal is to create some bird and append to bird list. So let's create that bird object, right? So let's say let bird equal to some bird object. So the name of the bird, so I have a list of iOS members, or let me add a newbie. So let me add, I don't know, Peter, right? So Peter is a newbie on iOS. Location, I believe he's from New York. Image, I have an image asset right here called newbie, so I'm going to use that image. So newbie, let's initialize count to 0. So I spotted Peter 0 times. So I create this bird object. Now I'm going to add it to this birds list. So I can just say birds. So this birds list corresponds to the one inside of this file right here. I'm going to append this bird. So now, just to make the code look a lot, or just to make the UI look a lot more, I guess, realistic, I'm going to clear the text field whenever I add a bird. That way another user can, or the user can add a new bird if they want to. So to do that, right, this count right here should be set back to 0. The name should now be an empty string, and the location should also be an empty string. So now let's see if that works. Let me add, actually, I'm not going to add Peter here. So this depends on whatever is passed in. So I'm not going to hard code it here. I'm going to use whatever is actually passed in. So I'm actually going to use name here. So this name corresponds to the property right here. So I'm going to use that instead. That way it will use whatever the user passes in. So name, location, image, I'll keep it as newbie. Count, let's make it counts. So I'm going to add Peter here. He is from New York. Let me increment count, say 4. If I hit add bird, you can see that whenever I change these properties, these views get updated automatically because I have that @state property wrapper to it. So now if I click view birds, okay. I think my code got deleted, but this should be inside of a navigation link. Yeah, I don't know what happened. Wait. Yeah, I don't know what happened. This thing should be inside of a navigation link. Okay, I'm just going to run the code because my code's bugging right now. Okay, there we go. Yeah, I don't know why it got deleted. That was weird. But let's say I add Peter here, make it New York, increment count by 3. If I click add bird, this thing gets reset, and you can see down here I have Peter added to this list. Okay, does that make sense? Does anyone have any questions regarding that? All right, perfect. So yeah, just to recap, you want to add @state if this view creates and it also owns this property. Now, whenever this property were to change, all views that use it will be updated automatically. So you can see that this view birds right here gets updated automatically. Same thing with these text fields right here. Okay, so now I'm going to move over to the lecture slides. So I already mentioned this before. The view creates and owns it. You want to use it for a value type. So in the example earlier, I had a string. I also had an int. So those are value types. You want to mark it as private for best practice because nothing should be modifying it. And then you want to use a $sign to indicate a two-way binding. So a read and write to that property. So what about reference types, right? I noted that this thing only works for value types. But what if you have a reference type? So this isn't part of the demo code, but I will quickly demo this other code right here. So I have a struct containing two properties, first name and last name. I hard code it to Antoinette Torres. And so now my goal is, if I were to change this text field, this text right here should change as well. So I create a user. This view will observe this user property. So I mark it with @state. Now this thing changes the first name. This thing changes a last name. So again, this is a value type because it's a struct. So now if I were to change the name right here, you can see that the text field gets changed automatically. The views get updated automatically. But the problem with using a struct sometimes is that you want to keep that same reference. If I were to have other things about this user, for example, a list of food objects that they like, I want to make sure that that stays there. So I want to be able to pass a reference. But if I were to change this property right here, that reference will be deleted. But I don't want that. So instead of a struct, what I want to use instead is a class because that keeps its reference. So a class, again, is a reference type. Now this thing will reload. Let's try to see what happens if I change this. So now you see that if I were to change these properties, this right here doesn't get changed. So what is going on, right? Why does it work for a struct but not for a class? So let's take a look at what's really happening behind the scenes. So earlier in the demo, all right, let's say I have this name property that contains a string. I add @state to it. So this right here is a value type. So if I were to change my name and put Liam Do there, the view on the right gets updated automatically. So this @state observes whatever is inside of this box right here. Now, if I have this right here, so I have a struct called a user. So if you've taken like 1110 before, I've made it similar to how it is in 1110. So I have a property called Vin. It holds a reference to the ID of this object folder. I have a user struct with these two properties. So now, if I were to change first name from Vin to Liam, on the right hand side, you can see that the view doesn't get updated automatically. This doesn't get updated automatically because the ID hasn't changed. So this right here is wrong. What's really happening is that you're creating a brand new struct. So that ID1 object folder gets deleted, this new one gets created, and I replace the reference to that ID with a brand new ID. Now this one has the new name, so it's Liam Bowie, and you can now see that because @state is observing the value inside of the box, it's able to update the view automatically. Now, instead of a struct, if I were to change that to a class, if I change my name to Liam, my first name to Liam, the view on the right hand side does not get updated automatically because the ID does not change. That reference still stays the same because it's a reference type. So how do we fix that? Well, there's another property wrapper called @stateObject. So instead of @state, I want to use @stateObject. Now it's going to yell at me because I need to conform to a protocol called observable object. So I'm saying, hey, this user is some object that is observable. So now if I were to change these values right here, you can see that it still doesn't work. Now the issue right now is that it doesn't know which properties to be watching. Earlier, in this example, I had, when this was a struct, this @state was watching over this entire box. But now I changed this to @stateObject. So I need to tell it which properties are going to be observed. So to do that, I will add @published to it. So let's say I want to change the first name. So now this thing will refresh. Now if I were to change Antoinette, you can see that it's now being able to observe the value of first name. If I were to change the last name, that doesn't work because it's not being observed. So You want to use @StateObject if you have an observable object, in other words, some kind of reference type that you want to observe. Any changes to the properties that are marked with @publish are notified to SwiftUI, and all the views that use that property will be updated automatically. And the view itself creates and owns the instance. So in the example earlier, that view created a user object. So in that case, I want to use @StateObject. So how does the diagram of that work? Well, I now mark this property with @published. Now I change my name from Vin, my first name from Vin to Liam. That view automatically gets updated because now this class conforms to observable object, and now the @state property wrapper gets changed to @StateObject. So it's observing some observable object. It's observing its @published properties. So now the ID doesn't change, but it's still able to update its views automatically. Does anyone have any questions about reference types? Nice. Okay, so in both of those cases, the view itself owns it. It created the user, it created the string, it also, it created and it owns it. But sometimes you want to pass in data between multiple views. In the assignments, for example, you have some text field value and you want to pass it to another view controller. Same thing in SwiftUI, you want to pass in data from views. So it's not always the case in which it will create and own it. You get it from some other external source. So this is where another property wrapper comes in, called @binding. So @state creates that property, @binding receives it. So it will read and write to the property that's owned by some parent view. So if I have a parent view that has an @state property, if I want the child view to be able to read it and to be able to modify it, that child view needs to declare that property with @binding. So that's actually what's happening behind the scenes with a text field. That text struct takes in a binding of a string, which is how it's able to read and be able to write to that property and update its parent. So with SwiftUI, you don't need to do any of that delegation stuff. All you have to do is just pass in that property and tell the child that it has an @binding property wrapper to it. So if the child were to change it, the parent will also be updated automatically. So this is also being used for a value type. We also have a reference type equivalent, which is @observed object. So it's the equivalent of @StateObject, but you're now passing it. So you're now receiving it from some other source. So same thing, changes to @published will be notified, and you want to use this if the view does not create or own it. So it's being passed from one parent. Okay, now that right there was a communication between just two views, right? You have a parent view, then you have a child view. But sometimes you want to share it to multiple views. In that case, we want to use another property wrapper called @environmentObject. So it's the same thing as @observedObject, but @observedObject requires it to be passed in from some parent, from one parent, whereas @environmentObject can just take it from some environment. So if you want multiple views to be able to access, to be able to share that same property, you want to use @environmentObject. Again, it doesn't create or owns that property. So I know that was a lot, but if you do create an app with SwiftUI, it's really important that you understand how property wrappers work, because that's like the most common things that a lot of developers struggle with, is knowing when and how to use those properties. So I kind of like briefly, so this is like a brief breakdown of how to use it and when you should use it. So if you're getting some data, if you own the data, if you don't care about changing it, if it's just, if the view only reads it and doesn't really, and if that property doesn't get changed, you can just use, like a var, right? You don't need to add any property wrappers to it. If it's mutable, right, if I were to change it and want my views to be updated, I would use @state. But if that was a reference type, I'll replace that with @state object. So now that's if I own that property. If it comes from one parent, again, immutable value, you can use a regular property. If you want to change it, if it's mutable, you can use @binding. That's for value types. Now for reference types, I would use @observed object. If it comes from the environment, you want to use @environment. So this is @environment. It's actually built into SwiftUI. There are a bunch of properties that every SwiftUI view can get from the environment. So there's like a bunch of built-in environment properties. So I won't list them there, but that is there for you to use. Now, if you have some @state object from some parent and want to be able to pass it to multiple views, that child view will need to use @environment object on it. So @environment is equivalent to @environment object, and the state is to @state object. Okay, now there are other ways the data could come from. We're not talking about backend integration for now. Let's say it comes from the local disk. So in lecture 8, we learned about user defaults, about persistence. So you can actually still read and write to user defaults by using these property wrappers. So you can use app storage to access the value of that property. Scene storage is mostly for if you're developing a macOS app, because a Mac has like multiple scenes. And then if it comes from core data, which is just essentially like a built-in front-end database, or you can use Swift data, you can use @fetch requests. Okay, does anyone have any questions? Yes?
Is there any downside to using states for immutable? I don't think immutable.
Yeah, that's in terms of memory allocation, I'm not sure. I don't think it actually makes it makes it consume more memory. I guess like the only concern as a developer is that if I were to read someone else's code and sees @state, I'm like, oh, this thing might be changed somewhere, right? Or same thing with marking things as private, right? You don't have to mark it as private, but it's good practice because sometimes you don't want them to change it. So same thing with @state. Sometimes I don't want them to change it, which is why if you don't need to change it, just make it immutable. That's a good question. Okay, any other questions? Right. So I'm gonna quickly show y'all a code base that uses SwiftUI. I'll show y'all volume. It's a lot more complicated than Uplift, so I'll demo or quickly show that. Okay. Okay, hopefully I don't leak out any secrets, but basically I have view models, which contains the logic behind your code. So you can see that I have a view model class that's an observable object. So these values right here, they are observed. So whenever these values get changed, right, if I fetch new articles from the backend, so I have a backend call. So the backend for volume uses GraphQL, which is different from a REST API. But I have this right here. Basically, it fetches articles, and whenever it receives it, so this uses combine, not like Almofire or any of that. But basically, what this code says is that you receive some articles, and then you update this articles property right here. So this articles property has @publish to it. So if I were to change this property, the view gets updated automatically. So whenever I refresh and I fetch new articles, the view automatically updates for me. I don't need to do the imperative approach of like passing in data. This thing happens automatically. So it's a very, very neat compared to UIKit. Now, in terms of @environment object, let me just So yeah, I mentioned something about like how built-in there are built-in properties from environment. So this right here is a scene phase property that's also built into a SwiftUI view. Well, let's see at environment object. So all views may have to share something about the user. So I have an environment object, which is some user data. So where does it get this user data from? Well, it gets it from some environment. Now, that environment could be a parent, and that parent needs to already create that view. So, I don't know if I'm able to see. So yeah, I have a user data object right here that contains some information about the user throughout the app. I mark it as an observable object. So let's say the person saves some article. This thing right here will update automatically. And so this cell right here, because it contains the user data, if I were to change that value, the view would get updated automatically. So this user data comes from the environment. Now I want to use at environment instead of at observed object because all of my views are accessing this property. So if I were to call flyer cell past, so if I do flyer cell past right here, if I were to call it, you can see that I don't need to pass in this property right here. I don't need to pass in this user data property. I do need to pass in URL image model as well as view model. So both of these properties right here are being passed in from the parent, but the environment object does need to be passed in because it's able to get that from the environment. Now, how does it get that? Well, you pass it in by doing .environment or .environment object. So the main view creates this user data object already, and then by doing .environment object right here, it's now passing it to every single view inside of content view. Now, content view is extremely massive. This is like the main view that runs the entire app. So I broke it down to multiple views. Now every single view will now have access to this user data. The same thing works with networking. If I want to use networking, I want all of my views to be able to do networking, I can pass in some network manager object. But yeah, so last but not least, let's talk about iOS 17. So everything that I told y'all for the last 45 minutes, you don't actually need to know that if you're doing iOS 17, but it is good to know if you do work on code bases that are before iOS 17. So iOS 17, Apple decided to make the lives of developers a lot easier. So you don't need to know at state object, you don't need to know at observed object. All you need is to import this module right here called observation. You mark this class as observable. So instead of making it conform to at observed object protocol and have at published, all you need to do is just say, hey, this class right here is observable. What it does is that it'll automatically look for changes within its properties and then be able to update its views. So I don't need at state object anymore. I can still use that same at state. The only difference now is now that this is a reference type, all I have to do is just mark it with at observable. So it's a lot more neater and it's a lot cleaner. But yeah, that's it for SwiftUI. Before we wrap things up, does anyone have any questions about SwiftUI? No? All right, perfect. So yeah, I'm gonna hand it off to Tiffany. Are there any like last minute announcements?